All right, let's do some more examples with the centers of triangles. If point G is the centroid, we know the centroid is made up of medians. Medians go from the vertex of the angle to the midpoint of the opposite side. So all of the sides of the triangle are cut in half. We also know that the centroid is cut so that we have a 2/3 and a 1/3, with the 2/3 being the section near the angle and the 1/3 being the section near the side of the triangle. So let's start GF. So GF is here, and if AG is 2/3, GF is 1/3, GF is going to be 1/2 of AG. AG is 26, so GF is 13. And AF, which is the whole distance, is going to be 13 plus 26, or 39. FC right here is 1/2 of the side BC. BC is 44, the median cuts in half, so FC has to be 22. Now GB, which is in our blue right there, is the 2/3 side of DB. DG, which is the 1/3 side, is 12, so GB has to be double, or 24. And then DB, of course, is going to be 12 plus 24, or 36. And that's the centroid. Let's move over to our next example. Still working at the centroid. And here we have all the interior, all the medians. We know all the medians. We know all the medians are cut 2/3, 1/3, 2/3 on the side that is by the angle, and 1/3 on the section that's by the side of the triangle. So if we start with LQ, which is right here, we need 2/3 of LN. LN 72. 1/3 of that's 24, so 2/3 of that is 48. QN is the 1/3 side. We know it's 24. 48 plus 24 is 72. We got that. We're good on that one. QP. QP is down here, and that is the 1/3 side of JP in the tan there. JP is 93. 93 divided by 3 is 30. Is 31. JQ is the 2/3 side, so it's going to be 62. And then QK down here is on the 2/3 side of MK in the green. MK is 78. 2/3 of 78 is 52. Let's look at a couple more examples. So for the next two, we got the circumcenter. Is the circumcenter. So we know that the circumcenter is made up of perpendicular bisectors. So the sides of I'm a little crazy with my lines. So the sides of the triangle are all cut in half. And all the segments that touch the sides are perpendicular bisectors, so they're all at right angles. And then we also know that the circumcenter is equidistant to all the vertices. which is the point where all the angles are formed. So not only does this give us a lot of congruent lines, but it also gives us a lot of right triangles. And wherever we have a right triangle, we can use the Pythagorean theorem if we know 2 out of 3 segments. So first thing we got to do, BE. So BE is here. EC is here. Since that segment's cut in half, we know we can set them equal and solve for x, because we're looking for BC, which is this entire guy right here. So we get x on the same side. Then we get x by itself. And we get x equals 4. So now that we have x equals 4, we want the entire thing, so we got to plug it into each side. And if we did this right, since we set it equal, we should get the same number twice. So 8 times 4 is 32, minus 11 is 21. Then we have 13 times 4 minus 31. And 13 times 4 is 52, minus 31 is 21. So BC equals 42. And we are done with question 7. Question 8, still dealing with a circumcenter. So still perpendicular bisectors, equidistant to the angles. So ultimately we want to find FC, which is this guy here. And we got a bunch of right triangles to do it with. So that'll probably help us. BP here is that. We got AP here, which is that. So they're congruent because they're from the circumcenter to the angles. Then we can set these equal. But before we do that, let's note PF, which is right here. So now let's solve for x. So 9x minus 29 equals 5x minus 1. So we get the x's on the same side. Then we get the x by itself. So we have x equals 7. And now we know the length of all of the segments, from the circumcenter to the angles. And it's going to be 9 times 7 minus 29. So 9 times 7 is 63 minus 29 equals 34. So here we got 15. Here we got 34. We want to find FC. We've got two sides of a right triangle. We can use the Pythagorean theorem, but we have to identify the hypotenuse. And the right angle always points at the hypotenuse. So we know 34 is our c squared. So we got x squared plus 15 squared equals 34 squared. So x squared plus 225 equals 34 squared, which is 1156. So let's get the x by itself. So x squared equals 931. Take the square root of both sides, and we get x equals 30.5. And we are done. For the last two questions, we're going to be using the incenter. And what forms the incenter? The incenter is formed from angle bisectors, and it's equidistant to the sides, and the sides of the triangle are congruent, or the sides of the angles are congruent. Across the V are congruent to each other. So we know all that to be true. So let's see what we're dealing with here. So MN, and we got NL, and that's from the incenter to the side of the triangle. So therefore, we can set them equal. So we got 9x minus 1 equals 16x minus 15. We get the x on the same side. Then we get the x by itself. We find out x equals 2. And we are looking for Kn. Kn's here. So we can plug it into either one of them to find out what Kn is. So 9 times 2 minus 1 equals 17. So Mn equals 17. All right, last review question, still the incenter, formed by angle bisectors. So RST, so remember we follow the letters. So RST is right here, and then STR, STR is right there, and we need this, and TRS is right here. Oh, and the first one, I colored that wrong. I did not follow that. So what do we have? We have all three angles of the big triangle. And we know that all the angles of a triangle equal 180 degrees. So we get 3x plus 17 plus 8x minus 32 plus 2x equals 180. So we're going to combine like terms. So we get 13x minus 15, because 2x plus 8x is 10x plus 3x is 13x. And 17 minus 32 is a negative 15. It's 180. We get the x by itself. 13x equals 195. So x equals 15. All right, we found x. What exactly are we looking for? We're looking for a measure of angle RSN, which is this one here, RSN. I colored it in properly this time, so we know. We need to find angle RST and take half of it. So we go 3 times 15 plus 17, because we're going to plug it in. 3 times 15 is 45, plus 17 equals 62. Take half of 62, so the measure of angle RSN equals 31 degrees. And we are done.